Hey guys, we will be doing more derivatives of natural logarithm functions, ln. Before we did take the derivatives of natural logarithm functions, ln of something, ln of 2x plus 5, ln of x squared plus 3, or ln of square root. And if you need to brush up this stuff, jump to these videos. All these links are down below in the description box. Go ahead and watch them. What if you are given something like x times ln of x, or let's say 2x times ln of 3x minus 1? You are given actually a product of two functions, and you need to take the derivative of this. Or it might look more scary and complicated, something like x ln of x plus 2. So how to handle this one? Or you might be given the overall form, something like ln of 4x over x. So how to find the derivative of this function? As a good rule of thumb, wherever you are given two things being multiplied and you need to find the derivative, what you want to use the product rule for derivatives. Now, if you bump into something like overall form, one thing divided by another thing, first of all, you have to apply the quotient rule for derivatives. And by the way, I do have videos on the product and quotient rules for derivatives, so also link is down below in the description box. And if you need these extra examples and to get this idea how to use it, when to use it, definitely go ahead and watch them. Actually, I do have a similar video for exponential functions when you need to use the product and quotient rule and you are given something algebraic function times the exponential function e to a power. Also, these links would be down below in description box, and if you need these exponential function examples, also jump to these videos and watch them. Anyway, I'm going through all of these examples and I'm going to give you this breakdown how to handle that. Alright, suppose you have x ln x and you need to differentiate it with respect to x. As a good rule of thumb, since you are given two things, two functions being multiplied, you are given a product of two functions. All you want to do, you want to use the product rule for derivatives. And here a quick reminder. So, say you are given u times v and you need to find the derivative. All it says that you need to take the derivative of u of the first function times the second function as is, plus the first function u as is times the derivative of the second function v. So your u function in this case, it's going to be x, so this is your u, and your v function is going to be ln of x, so this is your v. Y prime equals. So all it says, take the derivative of x, and the derivative of x is going to be just 1 times the second function ln as is. So you are going to rewrite it as it is, like so. Plus, you want to move to the next term. Now, your x function as is, as it is, so you don't want to change it, times the derivative of the second function. And remember that the derivative of natural logarithm of x, it's going to be 1 over x. That's the derivative from a standard table of derivatives. So in place of v prime, I'm going to write 1 over x. And again, 1 over x is the derivative of ln of x. And technically we are done. This is your derivative. All you need to do is just simplify it. So clean it up. You're simply going to ignore this one and look at this. X times 1 over x. So basically instead of this, x goes away. You are left with just 1, and I'm going to place this one first, plus ln of x is left over. So this is your final derivative for this function. Okay, here's another one. 2x times ln of 3x minus 1. Same steps as before. So your u function is going to be 2x, so you want to just match up. This is u. And this ln of 3x minus 1, this entire second term, is gonna be your v function. So this is your v. Alright, apply product rule at this point. So all it says, take the derivative of u. And the derivative of u, so the derivative of 2x is gonna be just 2. So x goes away. So write 2 in place of u prime times v. So the second function I'm going to write as is, as it is, like so. So ln of 3x minus 1. Moving to the next term, so you want to add, now, the first function u as is, so 2x in place of u in this formula, times v prime. So you want to take the derivative of the second factor, the second function, which is ln of 3x minus 1. Again, remember the derivative of ln is just 1 over this something, the entire argument. So I'm going to write 1 over, so times, basically 1 over this entire argument, so 3x minus 1 goes on bottom. And we are not done yet. You are given ln of 3x minus 1. It's not ln of x, like in the first example. So we have to use the chain rule. Again, the chain rule. And I'm laughing because I keep using it over and over. And by the way, if you need this extra help and if you need this gist of the chain rule, also the link to this, my first introduction to the chain rule videos, are down below in the description box, and go ahead and also watch them. Anyway, all it says that you need to take the derivative of outside function, which is ln, so we did it. It's 1 over 3x minus 1. And this function, this term gets multiplied by the derivative of inside function. Your inside function, what is inside your natural logarithm, is going to be 3x minus 1. So we need to take the derivative of 3x minus 1, which is going to be just a piece of cake. So the derivative of 3x minus 1 is going to be just 3. Remember that the derivative of any constant negative 1 is just 0, so negative 1 goes away. And the derivative of x is just 1, so x goes away. So you are left with just 3. So this term gets multiplied by 3 by the chain rule. And we're done. Technically we're done with the derivative. All you want to do is just simplify as much as you can. Rewrite the first term as this. So it's 2 ln of 3x minus 1 plus, so 2x times 3, you are left with 6x, and I'm going to place it on top of this fraction, and 3x minus 1 remains on bottom. So this is your derivative for this example.